Alright guys, let's not waste any time. Let's get started. So right in front of me is FreeCAD. I'm using versions 0.20.2. Maybe there's a newer version now, but I'm still okay with this version. So again, what we're going to build is a TX800 VTX mount. The company that built it is SpeedyBee. Okay, so I'd like to share how to build 3D models using softwares like FreeCAD. I may not be following the proper way of building a model, but I'm able to build models. Okay. All right. So yeah, this is the workspace, and this is where all the resources or components are being shown. Everything that you are creating, this is the area where it's being displayed. So the first thing that I need to, or the one that I usually do, is the drop down. By default, it will default to part. You have to be in part design. I'm not familiar with other stuff here. I've only used part design and where's the other one? I couldn't remember. Sketcher, I've used that. There's another one that I use. Draft, that's the other one that I was using, especially when making my own custom text. I use that. Okay, let's select part design, and this is what I usually click. We create part, and then the next one is we create the body, and then the sketch inside the body. Okay, and then you'll be presented here with the axis, and I normally pick this one, but you can pick anything based on the model that you are creating. All right, so earlier we measured the dimensions of the TX800 VTX, as well as the thickness of the bottom plate of the iFlight XLS 5.1 frame. And all right, so how I normally attack this is just random. I don't have any like exact process. Whatever I think, whatever comes to my head, that's how I started. So I'm gonna build a hole, a rectangular hole. This is where the plate will be inserted, and the dimension of the plate is 2.5 millimeters, and then I'm remeasuring the thickness of the plate just to make sure I won't be wasting time. Yeah, it's 2.5 millimeters, and then the width of the plate is, I'm using my digital caliper, it's 28. Okay, so this is the inner hole, the inner surface. So again, like what I said, it's 2.5, so I'm gonna put 2.5 millimeters here, and then this one will be 28 millimeters. And then I'll zoom in on it, and then sometimes I would recenter it. Most of the time I recenter it. Not recenter, I center it. Yeah, by clicking the nodes outside and then the center, and then you click this. And then the thickness of the TPU, I think 1 mm would be, I think, strong enough. Let's see, 1 mm, 1 millimeters. Yeah, I think that would be fine. Let's see what I couldn't remember. I have samples here of, yeah, this one is 2 millimeters. Maybe 1 millimeters is too thin. You know what this is? I'm currently holding a TPU washer that I made. It says 2 millimeters and it's thin. It's very light. I'm kind of worried. I'm kind of worried about elasticity. Yeah, I wanted to make it stretch because of something on the iFlight frame, which is why I wanted to make it more elastic. So that's why I was picking 1 millimeters. I can always use a heater blower so that I can soften the TPU, and then I'll be able to insert this 28 millimeter clearance on a 30 millimeter wide plate. Okay, I think, yeah, I think, you know what, let's try 1.5 millimeters to make it a little stronger. So in order to put the put a 1.5 millimeter gap between these two, you select the node. Oops. Select the node and that node, and then you click this. I'll put 1.5. And then this and this again for the bottom part. It's gonna be height 1.5. Okay, and then on the left side, you don't need to redo the height because we've already set up the height. What we need is the distance between the two, yeah, these two lines here. So I'll click that and I'll click this. See the changes? Both are now green. Both nodes are green. So I'm gonna select this and then I'm gonna put 1.5. Okay, what about the top part? Do we keep it as 1? This is where the VTX TX800 will actually be sitting on. So 1 millimeter is, I guess, too thin. Maybe I'll put here maybe 2 millimeters. Let's see. I'm gonna look again at the washer. No, maybe 2.5. I'm gonna put 2.5 millimeters with an infill of maybe 40%, so that way it's not solid. 2.5. All right. I think it's not thick enough, but it's okay. So the next thing I need to do, we are gonna close it, and then I'm gonna extrude it, and I'm gonna measure how much width that I will use for the mount. Okay, where's the drone? Here. So I'm measuring this part. That would be 17 millimeters. Yeah, 17 millimeters is good enough. So if you click this is for padding or extrusion, right? And then I'm gonna put 17 millimeters. It's gonna make it taller. All right, done. This is the top. This is the top. This is the lower part, the bottom part of the drone. Okay. Now we're gonna rotate it. This is the top, and this is where the TX800 will be sitting on. Now we need to build a wall. The size would be the same, 28 in inner surface or inner side. So I'll click this. It's now selected, and we're going to create the create sketch. I don't know if that's a bug. It vanishes. So what I usually do is close it, and then I double click this component here, sketch 1. All right. And then next we need to build the wall that I was saying. What I'll be doing next is I'm going to measure the thickness of the TX800. And let's see. The thickness is around 6 millimeters. Okay. That is 6 millimeters. Okay, 6 millimeters. But before I do that, I will use this external geometry tool, and I'm gonna click some parts over here, the lines, the borders. So that way, I'm telling the new object to adhere or attach or use the existing part or component. So I click that and I click this. You don't have to click everything. Because what I'll be doing is I'm going to create a border, right? So I have to click this. So now you notice those 4 nodes, they're now clickable. If you don't do that, you won't be able to click the line. Okay, I right click, and then next thing we need to do is to create a border. So yeah, I'm gonna use that rectangle tool here. Yep, so be careful, there's a different choices there. I just picked the basic rectangle. So I hover the mouse and look at the green node, circle node, it changes color. When the color changes, it means your mouse pointer is on the proper position. So I'll click, single click, and then see that thing changes to yellow, click again. Alright, perfect. If the rectangle doesn't turn solid green, it means it did not land on the proper node. Now we need to create why did I do this? But it's okay. Now we need to, yeah, I should not have done that, but it's okay. We need to create a 28 by 28 square. Okay, and then that's the height. So you click this, see it's parallel, so you put 28. That's the height of the TX800 board, and this one should also be 28. Okay, and the next is to make this center. Click that again, see that green thing, click that, click this, and then click this to make it center. So 28 divided by 2, there you go. It's just math, right? Okay, looks like, I don't know if this is wider than this. Maybe this is confusing me. No, I think they're the same width. I'm referring to this small rectangle area here. Okay, next thing is we need to center this 28 in this to make it like symmetrical or equal, so that the distance of this line here and this line are the same. So you do that by doing some math. You click this and you click that, make sure it's green, then you click the height, and 1 second guys, sorry about that. Alright guys, so the way to calculate this is by using math. Grab the width or the height or the dimension of the one that you're calculating, you divide it by 2, and then you minus it, and then grab the height of this, which I believe this is 17 millimeters. We'll have to divide it by 2 again, and then distance between these and these will become equal. There you go, it's 5.5. yeah, so they're equal now. I think something is wrong with, yeah, we have to go back. I really think this is different. So this is 28. I don't see any measurement at all. You know what we'll do? Let's do this. Let's see. Something is weird. Let me select this, and then I'll click this. No, you can't. Let's close. I want to open up the old one, the one with this one. Alright, so it is 1.5. No, it's the same. Maybe it's just my eyes. 28 millimeters. Yeah, it's good. So it's just my eyes. I thought one side was 1 millimeter and then the other one was 1.5. All right, we're gonna open it again. Yeah, all right. So where are we at now? So this is the same. Now this is the inside border of the wall that we're building. I'm going to create another rectangle, and you'll see what I'm trying to talk, why I'm trying to do what I'm trying to do. You'll see why. So this, and this. I want the wall to be 1.5 millimeters thick. 1.5, so that should line up right here, I believe. Let's see. Yeah, see? And then this as well will be 1.5. Yeah, perfect. And so with these and these, the height should be 1.5. Okay, perfect. And then these and these, height 1.5. Okay, looks good to me. Now we can close it. And then we will let us measure again the thickness of the TX800. I think it's 6 millimeters, right? Yeah, let's see. Oh, my memory is so bad. But I remember it's 6 millimeters. Yeah, 6 millimeters. Okay. To be exact, it's 5.5, but I'll use 6 millimeters. So the padding we will build or use is 6 millimeters. Oh, how come it didn't work? Why? What the? It didn't work. Oh, because of that line. That's a culprit. Yeah. So I forgot. So if you have lines like this is bad. So we have to delete it. Okay. To delete it, this is the tool you use. Delete that. Delete that. Delete that. Delete that. Now, if we do this, I think it's still gonna fail. You know what? Let's delete the lines that we added earlier. I knew we will have an issue. Okay, I don't see. Oh, yeah, this one as well. We should delete that. All right, now it's all green, right? We deleted the first rectangle that I created. All right, we're gonna close now. The padding should work. Perfect. And then the height of the TX800 is 5.5, but we're gonna use 6. Yeah, because sometimes, you know, printers, we're not sure if it's correct or not. Oh crap, I forgot one thing. Although it's not a problem, this can be used as a like for air intake. Yeah, I think that would be good. I think it's nice. I'm gonna put an opening here later, so that the bottom part of the TX800 will get some air. Yeah, I'll do that later. So I was talking about putting a Crossfire Nano support here. This is what I'm thinking of doing. I'm gonna measure the dimension of the thickness of the Nano RX. I'm referring to the Crossfire Nano RX. I'll make 2 here, and then I'll insert it, or I'll just extend a rectangle over here from here to here, right? That will still allow me to insert the TX800 around this area. All right, when I do that, the TX800 will be protected by that section, right? You know what? I'll do it now because I know it's hard to describe. So okay, let's do it. But first, before I do it, I'm gonna measure the width of TBX Crossfire Nano RX. So the width is about, let's see, like 12 millimeters, and then I'll make it 10, so that way the side of the RX Nano can still be secured properly by a zip tie. All right, let's do that. Okay, I'm gonna click this part, and then we will create a new sketch. And then I think this is a bug in FreeCAD, which vanishes that thing, right? So we'll make use of this thing so we can set this as a geometry. Okay, what is this thing called again? External geometry. So we can link. Yeah, create an edge link to an external geometry. And again, the width of the Crossfire Nano RX is 12 millimeters. I'm just going to make 10 millimeters. So from there up to right here. Okay. And then that's now connected to this line. So even if I drag it somewhere, it wouldn't go out. It's just gonna keep on moving that direction. Okay, it's gonna keep stuck, okay, or adhered or connected. So like what I said, the width is 12, but I'm gonna use 10 millimeters. Okay, that's 10 millimeters, and then the center of that would be 5. 10 divided by 2 is 5. So I just want to center this rectangle, so we'll put 5. Alright, this is where we will put the Crossfire Nano RX. So what I'm going to do is later, once we print it, I'm going to put hot glue here, or most likely the other one, the E. Let's see. It's called, oh, this is not E6000 anymore. It's Gorilla Fabric Glue, but it's still okay. This is also strong. It's as strong as E6000. Okay. All right, that would be good enough. And then I don't know if I should put some protection on this side. Maybe I should, similar to how I build my GoPro session camera mounts, wherein there's some protrusion here which prevents the neutral density filter from flying away. If I do that, is it required? Maybe, you know what, let's do it. I'm gonna make some geometry here, and then we'll use a different tool this time. We're going to use this one instead, because I want to create a non-rectangular shape, which is, I think it's called trapezoid. I think the shape is trapezoid. I couldn't remember anymore if it's trapezoid or rhomboid. I think it's trapezoid. So how come I cannot, what's going on? Did I click it? Oh, I did not click this button. So first I'm gonna start right there. I'm gonna click, single click. See, it's color yellow, right? Single click, and then this. Watch it. This is currently diagonal, right? But I'm gonna slowly make it parallel to the line, and you'll see a symbol will show up, meaning it can be, there you go. See that thing? It is telling us that it's now parallel to the other line on the left. So I'll click that there, and then click this again, and then I'm gonna close the gap, yeah, to make it a perfect trapezoid. All right. Okay, so now I just right click outside the space, outside of the object, so we can pick another tool. So right now, maybe I should set this to size 10 as well. Let's see, let's set it to size 10. Okay, size 10, not bad. And then this is definitely not centered, right? This is not centered, and look at that. See, we need to put some constraints. We can pick like angle between these two, and we will make this angle equal to that one. But for now, let's make it centered. I believe the length of this outside thing is about, I forgot, I think it's about 32. So I'm gonna click this and then select that line. Let's see what it is. Oh, it's 31. I was wrong. Okay. So 10, 31 divided by 2. Let's see if my math is going to be correct. I selected those two nodes, and then I'm gonna put some distance between the two, which is gonna be here. So 31 divided by 2 minus 10. Where did I get 10? I got the 10 from there. Divided by 2. That gives us 10.5. So this from this is also 10.5. Yep. What about this? What's the length that we should use? Right now there's nothing, right? It's freely moving. I think this is a good length. I can pick that, so I'll select it, and then I'm gonna pick this and maybe round it off. So it's 5.85. I can put 5.75 or 5, doesn't matter. Let's put 5.5. Okay, there's not much thing that we saw that change, right? So the next thing we need to do is figure out how far we want. We don't want it that far, that's too much. This one will be enough. Yeah, this thing. Right now I know it's hard to visualize. What the hell is he doing? Alright, so let's see. The length is 5.5, and we will make it centered. So we can do that similar to the method we used here. So select this thing, select that thing. Now both nodes are selected, and we will use the same tool again, the constrain vertical distance. Again, the math would be 31 divided by 2, close it in parentheses, minus what? 5.5 divided by 2. Okay, there you go. It's now centered. So it is centered, but the length of this is still not in constraint. So look what happens. See, I can just pick a length that I want, something that will look pleasing to my eyes. So let's see. I think this length is good enough, so I'm gonna select that. This time we're going to use a different measuring tool, constraint distance. It's not parallel, it's not vertical, so you use this tool. So that would be 4.5. I don't like something that ends with a it's kind of like odd looking number, so 4.5 would be okay. Yep, there you go. So that would be it. So we have built this one, right? And now we have a guide on how much we will set this one on the new one that we will be adding. So again, we'll click this thing, this tool, and then we'll create another trapezoid. You can just randomly click it. See? There you go. So now you're gonna ask me, Neil, this one is not parallel. How do you fix that? Sure, we can click this, select the item or the line that you want this to become parallel as well to that thing that you're gonna follow. So, and then this is the one, this is the tool that you'll be using. There you go. Now it's parallel, right? And then next would be, you can pick any side that you want to fix. I'll fix this as 4.5. 4.5. Okay. And then now we can do the same stuff again, but I have another idea. I'm gonna teach you a different solution. You can select this. This one is locked now. I cannot move this anything anymore. I can, even if it's not gonna move. But this one, since it's still not constrained, I can still move it. So you can do it this way. Select that and select this. Is it selected? The green? Yeah, I think it's selected. Oh, yeah, let's do it again. It's color orange, right? Or pink. So I'm gonna select that. Select this. Okay. Now you want to tell FreeCAD to, hey, I want this to become like same level, same line. So there's a tool for that, and I think the tool is this one. Constrain horizontally. Bam. All right. You can do the same thing for this. Before we do that, we can change this to 5.5. Let's change the link. 5.5. And then this. Let's do a horizontal constraint. Horizontal constraint. Okay. And then what else? I think this one is still not in constraint because we can. Yeah, I was right. Okay. Let's do that. I'm gonna select this and then select this one, and we'll do another horizontal constraint. Bam, done. So guys, did you notice when you see full green, or maybe it's because the way I set up the colors, it's now fully constrained, and you'll see on this left part, it's now fully constrained. I'm gonna press Ctrl Z, which is undo on the keyboard, so that you can see how this part looks like. There's one, what does DOF? I forgot what DOF means, but there's one left. And then you'll wonder, which would that be? Is it this? Yeah, okay. Oh, that one is moving. All right. So let us make this horizontally constrained with this one. Right? And then click that. Boom. And then see this fully constrained. All right. Now let's click close, and we are going to do a padding, and I am thinking of putting a padding of, I think 2 millimeters is good enough. Yeah, 2 millimeters. Yeah, I think that would be good enough. So again, underneath this is where we will put the TX800. Yeah, perfect. Okay. And this is where we will put the glue, and then the Crossfire Nano RX. And then after we've glued it, we are going to put 2 zip ties right here. Yeah, to make it secure. And what else? Maybe I can extend this and then extend it there. No, it's just gonna add weight. All right, I think that's good enough. All right, so what's next? Looking at the VTX now, there are 2 connectors that we have to make. We have to make 2 openings for these 2 connectors. One is for the UFL, and the other one is for the GST. So we have to put a hole here and right here. Right here, okay? So let's see. Let's see, it's somewhere in at the bottom. I'm gonna use my caliper again. The width that I must put for the connector is 9 millimeters. Okay, I'm gonna measure the real JST connector because I'm not sure if 9 millimeters is enough. Okay, let's see. Oh, the JST connector is just 7 millimeters wide. So 9 would be perfect. 9 millimeters for the hole, okay? And then 9 millimeters for the hole. Where is it? And then for the height, I don't know if I should make a full. I think it's okay. Yeah. If I make an opening at the bottom, will it make it weak? Because this is 10 millimeters, right? If I make, let's see the distance. That's 6 millimeters, yeah. And then I put 2, and then this, what's the size? That's about 1 millimeter from the top, from the top here, right there. 1 millimeter, so I can make a hole right there. 9 millimeters, right there. 9 millimeters. Okay. So this will be a little elevated, which is okay. Yeah, so air can. You know what? Let's see how it's gonna look like. I'm just worried about the strength, the durability of this TPU. I think I should not worry about, quite honestly. Okay. I double click that, and then we want to add a hole there, a rectangular hole. So I'm gonna click this. I'm gonna click this. Okay, I'm sure it's hard to understand, right? So I'm gonna move it, and then let us measure the total height of the female JST connector. So right now it's showing me 4 millimeters. 4. What about the real JST connector? Let's see. It is, oh, it's even shorter. It's 3. So 4 would be good enough. So let's make a 4 mm high hole. Where's that rectangle? Okay. So let's click this top so it's facing us again, and then I said 4 mm, right? So click that and then change the size to 4. So I'm kind of worried that it might be too thin. It will make it too thin. We'll see. We'll find out. I said 9, right? So that's the hole for the JST connector. So if I do it there, see that part over here? I don't know if it's gonna affect the strength. If I bring it down here, that makes this thing strong, and this one, I don't know. I said 1 mm from top. So we have to do that. 1 mm from top. Okay. And then the bottom part. So if I do that, this is the only piece I'm worried about. This thing, yeah, this top. making this thicker won't actually help. So if I put it there, let's imagine we've made a hole. And because you know what, when I'm building mounts, I always think about, what if it crash? I mean, what about a severe crash? Which part will break? So I always think about that. So this part, this is just 1 millimeter. That's very thin, and will most likely affect. So if I do it that way, what if I make it wider? Just for this part, not for this part. Make it wider here. By doing it that way, will it help? Yeah, it will help. Yeah, and then this part, I'm not worried about the lower part. I don't care if this part breaks. Yeah, that's normal. You know what we'll do? Yeah, let's make this part, let's add a part here, so it will make it a little strong. This will add support for this area. Yeah, this part. Okay, let's do that. So I'm going to use this part again, this tool. We'll click that. We'll click this, and then we'll click top, so it's flat, and then we will zoom in, and then we are going to make use of this tool. Okay, I'm clicking the corner, and then corner here, and then I'm gonna pick some distance. Maybe this is just 3 mm, and then close it. All right, let's see. So, oh, you know what? We can't do that because I can't do, because here I want a pad, but this one I want to, what's this tool called? Oh, it's not shown. So let's undo this. Control Z. Yeah, okay, that's it. Let's close it. We'll do it later. We'll make a hole first. So to make a hole, we will use this tool instead of this one is the padding. This one is making a pocket. Okay, that's it. Okay, now we are going to add support because this part is really weak, trust me. So we'll make it a little thicker. Let's click this, either this one or this, doesn't matter, and then we'll create a new sketch. Okay, a FreeCAD bug. Double click sketch 4, and then we will use this, so we can select this thing and this thing, and then we'll zoom in, and we will use this tool to create a triangle. After we've created a triangle, we will pad it. All right, so let's see the current length of this one. So I selected that line, and then I'm gonna select this. So that's about 3 millimeters. How wide is that? 3 millimeters. Doesn't matter. You know what? Even if I put 4, this part, this area up to this area won't change a lot. So I'll just pick 3. Okay, let's do the other side. Let's do this again. The geometry. Select. And then this tool will make a triangle. And then this one. Right click on the area and then select the line and click this. 3. All right, we're done. Let's see. Is it the same? Yeah, we're the same. It's the same. So next, we'll have to do that on the other side as well. We will see. Oh no, we don't have, because The other hole that we will make is small. It's circle. It's for the UFL connector. So the next thing I need to do is to extend this, make a pad so that it's as thick as this one. Oh, why it didn't work? What happened? Oh, I have to reverse it because it's going towards here. So you have to click reverse. There you go. And then, so what's the width of this? What's the width of this? You can do that by showing this surface, right? And then changing the dimension to up to face. When you click up to face, the next thing you need to do is just click this surface. See? Perfect. Now, what we just did is we added support for this thin area. So that's a little stronger now. Yep. Okay. Let's control save because I have not saved this work. I have not. Yeah, this is gonna be the first time saving a TX800 mount. Okay. Now we'll make a hole for the UFL connector. So I'm gonna measure it again using my caliper. But where is the TX800? Okay, it's right here. So the top part from the bottom, from the top part of the UFL is about 2 millimeters. Okay, and then opening at the bottom. Yeah, it's okay. Doesn't. So where are we? We are going to make it here. We'll create a hole here. All right. Oh, the width of the hole. That would be. We can use 6 millimeters this time. Okay. So let's click this. Create a new sketch. Close. You know what? I should reach out to FreeCAD developers, and I'll bring that up to them. What's going on here? Is this like the other way? Yeah. Okay. We will reverse it. We will. I don't know why it did that. So now let's click bottom, and then we will select this tool again. This and this. I think that's what we need. And then we will create, I don't know if we should create a circle this time because it's circle. No, I'm gonna use rectangle. And then I said the width is 6, right? Yeah, 6. What about the height? The height would be 4, or let's do this. I said 2 millimeters from top. Two. Oh my God! It looks like I didn't measure the center earlier. Did I? Yeah, I didn't measure. Damn it! See, I forgot. See, it's not centered. Jeez, damn it. See? Oh my God. I'll fix it later. I forgot about that. Okay. Yeah, I noticed when I was doing this. Oh, my mouse is annoying. So 6 divided by 2 is 3. Okay, that guy is centered. And this one is 2. And then I think it's okay. So we can make it wider. Yeah, because we're just making a hole, yeah. I don't need to measure it because I don't want that thing left there, so we're going to put a cavity as well. But this is centered now. That's 2 millimeters. Okay, let's close it, and then we're going to you'll see what I'm trying to talk about, what I'm trying to describe. There you go. That's what I was trying to describe. I don't need the bottom part. This is for the UFL. Okay, I think we are done. Yeah, I think we're done. Yep, I'm gonna put some holes here because I think I'll have a very hard time inserting the this part into the iFlight frame because of that something. There's a protruding thing on the side, so I'm gonna make a hole. Let's see. I think this is good enough. Yeah, it's gonna be hard to print though. There's tons of support. Yeah, maybe if I do it this way. You know what? Let's build the hole now. I'm gonna build a hole on this side. So I'm gonna click this. Gonna click this. Where's that new create sketch? All right. That's that annoying bug. Now it's like that, and you cannot see because it's the inside, right? In order for you to work on that thing, you'll have to click sketch and then view section. Look what happened. See? Now we have access to the inside. So let's make it flat by clicking left, and then let's rotate it. I want to make a hole here. The width of this, if you remember, is 17. So we'll make use of this geometry again. And then we will create a rectangle. All right. This area will become a cavity, an opening. So you don't want this part to be so thin that it will what's that word? It will compromise the strength of the bottom part, the one that will be the one where you will insert the bottom plate. So let's take a look at the distance of this from this. I don't know. So that's about, oh, how come it's 0? Oh, because we rotated it. So that's what happens when you rotate and you rotate and you click the wrong tool. Let me do it again. Click that, and then we will click this. I know it's this one, right? Because we rotated it. So 3 millimeters, that's too thin. Maybe 5. Let's see if 5 is strong enough. And think about severe crashes. Yeah, 5 may be strong enough. Although the width or the thickness of the support is only 1.5 millimeters, so I think 5 millimeters is not enough. What if we do 6? 6 or 5? So 6, 17, 5 or 7 millimeters inside area. Let's do 5. So that will be the hole. This will be the kind of like, we can call it leg support. All right, that's good. Okay, so now we can make a hole there and here in one swing by doing this. We'll have to click 2 dimensions. 2 dimensions, right? So I think this one, the lower one, is for this one. So the width is 28 Let's try 30 here. Let's put 30 or 35 just to make sure. There you go. See this? Yep. Okay, I think we're done. Okay. Yeah, we're done. We can just make it a little aesthetic. So let's click the corners and we'll make it aesthetically pleasing. Maybe 1.5. Oops, too much. 1.25. There you go. And then this one, I like this to be rounded. Okay, I'm holding the control so that I can select more lines. Oops, what happened? Okay. And then zoom out. We've selected all four corners, and then we'll click this tool again, which is the fillet or fillet. And then yeah, it makes it like that. Maybe 1.5. I think it's good. Yeah, it also made it even stronger there, right? And then this part, I want this a little soft. Let's make it maybe 3. Yeah, that's good. Click save. Okay. And then looking at the TX800, the corners are rounded. Big rounded corners. So we'll put 4, I guess. Let's see. Okay, zoom out. Rotate. Hold the control key. Oh, did I click it? Oh, I clicked the wrong one. There you go. Okay, there you go. Zoom in. I'm having a hard time clicking the line. Okay, zoom out and drag, and then last one here. Zoom in. Hold the control key. Okay, zoom out. And then click this. I think 4 would look great here. Yeah, 4. So that's the shape of the TX800. Yeah, and especially it's just 1.5 millimeters, so it will it's elastic, it's TPU. Okay, and then corners, this looks ugly, so we'll do the same thing, but I guess I'm gonna use 3 only, so it's not too thin. Zoom in, and then fillet, put 3. There you go. That looks nice. Yeah, that makes it still strong. It's thick. Yeah. What if we put 4? Let's see. I don't know. It will be less TPU filament that will be used. Okay, I'll use 4. Now let's go right here. Now this is for the UFL. We will put maybe 2 here. Zoom in. Okay, zoom out. And then that thing again. Let's try 2. Yeah, looks good. And then I hate sharp corners. So let's change this to 2 maybe. Oh, it didn't work. Oh, you don't have to select that. What about 1.5? 1.5. Yeah, looks nicer. Okay. And then maybe this. What about 2? 1.5. Right, there you go. It's looking nicer now. Yeah, I think we're good. I think we're done. Okay, so again, we will put the glue here, and then we will mount the crossfire here, and then what's next? Zip tie. And what else? The VTX would be secured. I don't know if we have to. You know what? The TX800 will be secured because of this part. Yeah. Plus this 2 here. It will prevent it from flying. Yeah, I'm pretty sure. If I'm anal, you know what I'm gonna do? I can put a glue here on this yellow. That won't fly anymore for sure. Yeah, I can do that as well. Yeah, I think it looks great. Maybe. This do we need? I don't know. You know what? No, we don't. It's just a waste of TPU. It's just a waste. We're just adding space. If I add this to here, no, it's not a good idea. I think we're good. Oh, let's press Control S. All right, perfect. Yeah, I really like it. Do you guys see anything? Oh, what's that hole? Oh, just for me to be able to, because of that thing, I think it's for the 30-30 holes. That's why there's a protruding thing in that iFlight plate. Yeah, this will just allow me to be able to extend this part. Yes, or stretch. The proper word is stretch. Yeah, I'll do that. All right, guys. What the next thing that we need to do is we need to save and then press Control A, and then we will export this as an STL file. Oh, it's already in STL. And then I'm gonna put text amount STL. Yeah, those are all the things that I was working on. All right, save. That's done. It's already saved. Okay, the next software that we need to use is Cura or Cura. All right, guys, let's start Cura. All right, guys, we are now going to generate a file that is going to be compatible with our 3D printers. And the tool I use is called Ultimate Cura or Cura. And if you remember, I created or exported the mount that I built in FreeCAD as an STL file. And yeah, this is it. Okay. So that's the mount. I'm just rotating it. Okay. And now you have to think about, like, when you print models, you have to think um, in such a way that if I mount it this way, if I print it this way, will it be strong? So that's how you think. That's how you. That's what you do before you print something. And then also, if I put the object in this orientation, how much filament will I actually use? So right now, if you see red, that means Ultimate Cura is going to add support to be able to print that section. So if I see how much I'm gonna be adding, that means I cannot print this way. I mean, I'll be able to print it this way. I'll have a very nice hole, which I like, but I will have to add support. You'll see it once I slice it. So that one will have an extra TPU because it will have to add support to be able to print this part. Yeah, so now this kind of orientation is really nice for the hole. It's gonna be clean. There won't be any support because the way the printer works is like layer by layer. Yeah, it's like that. So you know what? I'm gonna slice it so you can see how it's gonna print it. So slicing it will tell you how a model will get printed, right? And this slider will tell you each layer. Yeah, see that part, that color cyan? It's the support in order to be able to print that area. If you don't, it's gonna sag and it won't print properly. That's why you have to do it. There are certain angles that you don't need support. Yeah, so that's what's called splicing or slicing, sorry. All right, so how much grams will I be wasting if I do this kind of orientation? I'll be using 7 grams right there, and it'll take about an hour and 36 minutes. What if we change the orientation? Let's do that. So let's go back to prepare, and then click the model, click this, and then what if I rotate it? What if I do this as the flat side facing the bed? This is called the bed. You can use the red by rotating, or the quickest way is by selecting this area. Select the surface, select that, and then which part of the model that you want to use as the surface facing the bed. I just click this. There you go. Now if you do it this way, look what's gonna happen. I am worried about the support. Look what's gonna happen. I click preview. See? Look at that. So especially the hole where the bottom plate is going to enter, that will have tons of support. It's gonna be hard to clean. And I use pliers to pull this stuff. Let me show you what I'm talking about. See? Oh, not that part yet. See, that's the support, the cyan. In order to print the upper part of the thing that touches the bottom plate. That's gonna be hard to remove, right? Yeah. It's lesser grams, 1 gram lesser. 20 minutes shorter. Yeah. Oh, the infill that I picked was what? Oh, 50%. 50%. I think it's okay. It's gonna be soft though. Let's see. Yeah, see that part? That's 50% infill. If I pick 100%, you won't see any triangles. So you have to study before you create the printable format, which is the .g code extension. All right, so let's head back here. Maybe change the infill to, you know, I'll pick 100. Did I type 100? Where's the 100? It's gone. Where is it? Oh, here. I thought I typed 100. What happened? Yeah, and then click slice again. You won't see the triangle anymore. Okay, let's move this up. See, there's no more triangle. So having 100% infill is more stronger than the previous infill that we use, which is 50%. Lesser TPU means more. It's gonna be more stretchy or flexible. This one is gonna be stronger. Yeah, and 7 grams. Oh, let's go back to prepare. And I'm kind of worried about the support that will be put here, and I don't want to clean that part. I want it clean. So select this and then select the surface. I'm gonna use this surface. So inside part will be easy to remove. So yeah, so I'm fine with this approach. Yeah, with this orientation. So maybe this is now gonna be 8 grams. Oh, it's still 7 grams. Cool. Let's see preview. And then I'm rotating it so you can see. Yeah, it's 100%. That's the support, the cyan. Yeah, right there. Yeah, I think I'm happy with these. Yeah. Did I miss anything in the drawing? I don't think I miss anything. Yeah. So now let's confirm our last. Let's confirm. Make sure what we selected here is correct. 100% infill, and then the brim. Printing temperatures 230. Yeah, it's okay. Okay, that's good. So now, if I click save to removable, it will save it as a G code. Right now, it's pointing to the SD card. You know what I'm gonna do? I'm gonna put it save to this, and let's see where it's going to get saved. You know, or no, you know what? I'm going to select removable. Oh wow, I think I broke it. I cannot click it anymore. I think it froze. Yeah. Yeah, I think I broke it. Yeah. That's crap. But anyways, what I'm gonna do, I'm gonna save this file as a G code, and then I'm gonna start printing it, and you'll see the final print later after an hour. Okay? Alrighty guys, later. Thanks.